So let's say if you want to do a standard neural network, right, which is basically a set of hidden layers that we have, then in that case what we will do is we will basically have this x1, x2 and so on, that will be the input and output, right? And what we can do is we can have this 9 inputs that are there. For example, the problem that we are doing, which is represented by tx is the maximum number of length, so this will be 9, and this will be output also layer will also have 9. Now what is the dimension of this one? The dimension of this one is 10,000, dimension of this one is 10,000, and we are stacking them together, and if you have 9, right, sequence, then this is a 90,000 dimensional vector, whereas the output is essentially a 10-dimensional vector that we have, 1 0 1 0 and so on. Now you can see, if we have, first issue is, if we have a 90,000 dimensional vector, the number of parameters, first of all, we will need for us to learn this, input to output mapping is going to be huge. That's one issue. The second issue is, how do we deal with the case that if we have multiple, sentences which have multiple word length? So some sentence might be 4, some sentence might be, 20 words sentences. And how do we deal with that situation in this fixed input and fixed output architecture? One way to deal with that is, we make sure that, the number of x's that we have are inputting is probably equal to the maximum length that we can have in the overall thing. So in that setting, we will maybe, if the maximum number of words that comes in the training set is 20, then this could be a 20-dimensional input. Now 20 times 100 is 200,000 input vector. And now if we get a word, sentence which is only 4 words, we are only going to be using first 40,000 input vectors, and some of them are activated, right? Not all of that is activated. So in that setting, a lot of things that we have stored is not going to be providing us any useful information in general, right? So a lot of them are 0 0 0 for the 4-word sentence, and they are useless, right? So that's one issue. And the second issue is, it does not take into account the sequence. For example, the x1 and x2 can appear in different sequences, right? And so you have to account for that fact, and this fixed architecture does not also deal with that issue. And this is why typically we tend to use what is known as recurrent neural networks, which are modified version of an architecture that helps you in dealing with these two issues, the fixed, non-fixed sense issues, and also the sequence issues, which is important for many class of problems that we have. Okay, so let's talk about the RNN architecture and how it is useful in many places, right? So what is typically there in the RNN architecture? You have two things, and I will point those out. First of all, you will take an activation as an input to a hidden layer or a set of neurons which is going there. Then this set of hidden neurons will also take an input. So this is the word that we have, and it probably takes the input A0, and then it does two outputs. One is the output, which is the label of the first. For example, if this was the name, let's say it was Max, then this label is going to be 1. If this was and, then this label is going to be 0, right? Because that's not a name, okay? And then what it does, it passes on, and it basically takes, this network takes two inputs, x1 and a0, and outputs two things, y cap 1 and an activation a1, which is used by a second layer. Now the second layer takes input A1, and it takes the second input and it outputs two things, which is y cap 2 and A2. And this essentially allows this sequence, and this allows us to basically capture the sequence dependency, because the location of x2, what word is here, is dependent upon x1, and that is captured by some information passing that is happening through this A1 activation that is going on in this overall architecture that we have. Okay, so again, what we are doing here in the third one, x3 is there, y3 is output, a3 is output, and so on, and we proceed probably for this problem where we are interested in basically taking the last word as an input and last word output is there. Now one caveat that I want to make, typically the activation A1 and A2 and A3 that are going to be there, they will store values. And as we will talk about going forward, this activation A0, which is at the beginning or the first layer, it is essentially going to be zeros. There is nothing there. But in order for us to be consistent and showing that we have different activations which are passing from the previous layer, and then we have input and output mapping that is going from the same layer, that is represented in this diagram, and that's why we have A0. But essentially this A0 in general invariably is going to be 0, whereas A1, A2 and A3 they are going to be containing some values.